After the conclusions, we are solving the second question. Cot theta into tan of 90 minus theta. Cot theta into tan of 90 minus theta minus secant of 90 minus theta into cosecant theta plus, just keep on listening sir, plus sine square of 25 degrees plus sine square of 65 degrees. Sine square of 25 plus sine square of 65 degrees plus root 3 times of tan 5, tan 15, tan 30, tan 75, tan 85. Whatever we have discussed till now, I am combining all these models and I am putting in a single question. I believe that your idea is very clear why I am discussing this question. Now see here, same logic I will implement. Same logic. Can I say that? Can I say like this sir? Cot theta, tan of 90 minus theta is again nothing but cot theta, right? Tan of 90 minus theta from allied angles, it is nothing but cot theta. So cot theta into cot theta is, it is cot square theta, right? It is cot square theta minus secant of 90 minus theta is nothing but cosecant theta. Cosecant theta into cosecant theta, it is cosecant square theta, right? Cosecant theta into cosecant theta is cosecant square theta. Now I also told you another thing. Can I say that this is 25, this is 65, this 65 is nothing but 90 minus 25. That means I am just writing step by step for your understanding, which you can eliminate in your examination hall. So this is sine of 90 minus 25, it is cos 25. Cos 25 in square is cos square 25, right? Cos square 25 plus the last terms are root 3 times of tan 5 and tan 85, the product is 1. Tan 15 and tan 75, the product is 1. Tan 30 is only one thing which is left out. Tan 30 value is how much? 1 by root 3. Now if I simplify further, we know that 1 plus cot square theta is cosecant square theta. So cosecant square theta square theta, the value is nothing but minus 1, right? The value is minus 1 plus sine square theta plus cos square theta, value is 1 plus 1 by root 3 into root 3, it is 1. What is the answer? Final answer is 1 over sir. Whatever we have solved till now, allied angles concept, or it can be sin square theta plus cos square theta concept what we discussed in yesterday's class, or it can be making the complementary angles, sum as complementary angles and then telling that the product is equal to 1. That means tan alpha into tan beta product is 1. Any of these things whatever we have discussed, everything I combined in one single question and I have drafted this question. Answer for this question is 1. I hope the idea is clear. Answer for this question is 1. Shashikant, there is a plus or into. Which question are you referring to, sir? Which question are you referring to? I think you are referring to my previous question. Correct me if I am wrong, Shashikant. You are referring to my previous question. Tan 2 theta into tan 4 theta is equal to 1. You need to find sin 2 theta plus cos 4 theta value, right? Shashikant, it is plus here, it is into here, sir. Even if it is, think logically, forget about this plus. Even if it is into, you know how to solve it, right, sir? Because this value you got it as 1 by 2. This value also you got it as 1 by 2. Suppose if it was into here instead of plus, you would have got answer as 1 by 4. Because the question is asking for plus, you got the answer as 1 by 2 plus 1 by 2. What is the difference in these two? There is no difference, right? Just a calculation. Shashikant, is that the question which you are referring to, sir? I want to take each and every student's doubts and then I need to solve it. I am more interested in clarifying your doubts. Shashikant, is that the question which you are referring to, sir? It makes no difference. If it is into, multiply at the end. If it is plus, add at the end. That is the only difference that you need to take care of. How minus 1? Raj Sharma, How it is minus 1, Raj Sharma? That is where you need to be very, very strong with your identities. Yesterday I discussed 1 plus cot square theta. 1 plus cot square theta is nothing but equal to cosecant square theta, Raj Sharma. If I shift this cosecant square theta to the left hand side and 1 to the right hand side, it becomes cot square theta minus cosecant square theta. If plus 1 on the left hand side goes to the right hand side, it becomes minus 1. That is what I wrote here. Raj Sharma, if it is clear, please comment, sir. How minus 1? This is how it is minus 1. Now see here, sir. This is the beauty of learning the concept, and that is why I keep on stressing you. You don't need to by heart these values. Now see here. Beautifully we can structure all these things, sir. This is exactly where I want my student to be so beautiful in the way they learn the concept rather than other people. Everyone please pay attention for my next 5 minutes. Now if you remember, think logically, sir. Hypotenuse square is equal to opposite square plus adjacent square. This is nothing but Pythagoras theorem, and I told you that suppose for example I will divide both sides by hypotenuse square. If I divide both sides by hypotenuse square, this becomes like this, right? This becomes like this. Hypotenuse square by hypotenuse square is 1. Opposite by hypotenuse is sin theta. So square is sin square theta. Adjacent by hypotenuse is cos theta. Square is cos square theta. That means first identity which I derived is, I discussed all these things in detail. Sin square theta plus cos square theta is equal to 1. Second identity, similarly, instead of dividing by hypotenuse square, if I divide by adjacent square, I will get another identity. Or if I divide by opposite square on both sides, I will get another identity. That means the other two identities which I got is 1 plus tan square theta is equal to secant square theta, and the last identity which I got is 1 plus cot square theta is nothing but equal to cosecant square theta. Now listen carefully, sir. Like this we discussed so many things, so many identities we discussed, and we thought that we need to remember all these identities. No sir, please do not study in this methodology also. Yesterday I taught you in this method, but yesterday is yesterday. It is already a cancelled check. I did not teach you something else in yesterday's class, probably which we will learn right now in our today's class. Now listen carefully. If I draw a hexagon, sir, why are you taking an hexagon, right? Why are you taking a hexagon? Because hexagon is something which is having 6 sides, and hexagon is something which actually has 6 sides and 6 vertices, and I also have 6 trigonometric functions. Listen carefully, sir. Let me draw an hexagon for you people. Everyone please listen carefully. There is a beautiful learning. You don't need to remember sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is secant square. 1 plus cot square theta is cosecant square. We will derive all those things so beautifully, and we will remember in the most easiest format. If you think that whatever I have explained in yesterday's class to remember is difficult for you, now listen carefully, sir. Can I say that this is an hexagon, there are 6 vertices, right? There are 6 vertices. I will join the diagonals of hexagon. Listen to the next 5 minutes carefully. I will make your trigonometric identities or formulas or whatever it is look like stupid in the next 5 minutes for you people. Just keep on listening to it, sir. Can I say that if I join all these diagonals, so if I join the end points, if I join opposite vertices, in fact, these are the two things which I joined. Similarly, the diagram might not be drawn to the scale. Just adjust with this, sir. These two I will join. Similarly, I will join these two. Now, the middle value, whatever the point where 3 lines are joining, that point, I will name that point as 1, right? I will call that point as 1. Now, think logically, sir. Can I say that we know a identity already saying that tan theta is nothing but equal to sin theta divided by cot theta. Everyone listen, sir, you will enjoy this concept. Tan theta is nothing but equal to sin theta divided by cot theta. Now what I will do is, this tan theta I will put it as one of the vertices here, right? Tan theta I will put it as one of the vertices. Sin theta I will put next to tan theta. Next to tan theta I will put sin theta. cos theta I will put next to sin theta. This is how I will write. And the other three vertices, three more trigonometric functions are there. Can I say that if this is tan theta, opposite I will call it as reciprocal. It is cot theta, right? Opposite is cot theta. Now see here, think logically. Can I say like that? If I divide this diagram into two equal parts like this, now this right hand side part, this is the right hand side part, this is the left hand side part. Right hand side part, I will write all the c values. This is starting with c, this is starting with c. What is the other c trigonometric function? It is nothing but cosecant. I will write cosecant here. 5 are over, the only thing left out is secant. I will write secant here. Now this is the thing which I will make use of to understand so beautifully, right? To understand so beautifully. Now listen to this carefully, sir. This is exactly what I will make use of in all my understandings in my next 5 minutes. Listen carefully, sir. Can I say that if I think logically like this, sir? I wrote it like this. Tan theta, if I go in clockwise direction, for example, tan theta is nothing but clockwise. I will go like this. I will go like this clockwise. One diagram understand, rest all we will be solving very fast. Forget about this arrow mark, right? If I go clockwise like this, now think logically, sir. Can I beautifully derive like this? Tan theta is nothing but equal to sin theta divided by cos theta. If I take these three values, first value is nothing but second value divided by third value, which I wrote it here. Similarly, what all can I write it like this? Suppose for example, if I take this as my first value, sin theta is equal to, let me write it for you people, sin theta is equal to cos theta divided by cot theta, right? Sin theta is nothing but equal to cos theta divided by cot theta. Similarly, can I also write like this? Yes, you can. If I take with this, if I start with this trigonometric function, cos theta is nothing but equal to cot theta divided by cosecant theta. You can check it out, sir. Everything will satisfy. You don't need to by heart any of these values. Cot theta is cot theta divided by cosecant. Similarly, if I start with cot, cot theta is equal to cosecant theta divided by secant theta. Take anything for your matter. First value will be equal to second value divided by the third value. Similarly, this cosecant can be written as, if I start with cosecant theta is nothing but equal to, take the next two, secant theta divided by tan theta. I hope you are able to understand so beautifully. Secant theta divided by tan theta, and the last one can be written as secant theta is nothing but equal to tan theta divided by sin theta. Everything can be derived so beautifully, sir. No need to remember any of these trigonometric formulas. If you know this hexagon, everything can be derived so beautifully, and that too whenever you require to derive. Similarly, whatever I have taken till now is in clockwise direction. Sir, will it hold good? If I take anti-clockwise direction, definitely it will hold good, sir. Take an anti-clockwise direction. If I change the reverse, if I reverse the direction of my arrow marks, if I change my direction of arrow marks, think logically, same thing you will get it in a reverse way. That's the only difference. Can I say that if I take it in anti-clockwise, suppose if I take first one tan, so this tan can be written as second one secant divided by third one cosecant. Tan is secant divided by cosecant. Yes, it is absolutely true. You take anything. If I take cos, this cos can be written as, this one is sin, this is tan. Cos is sin by tan. Yes, cos is definitely equal to sin by tan. You take anything. Suppose if I take cosecant, this cosecant can be written as, anti-clockwise I am going, cot divided by cos. Cosecant is cot divided by cos. Like this you can derive so many trigonometric functions by using one simple thing called as a hexagon, which is actually a superb thing. It is called as a super hexagon. It is called as super hexagon? Kindly comment in the live chat if whatever I have told you right now is clear, because I am not going to conclude or stop this with this super hexagon. I will teach you much more things, how to derive some other beautiful identities in trigonometry by using super hexagon, because I don't want my student to by heart like all the other students does it in so many other institute. Kindly comment if this is clear, sir. This is one thing which I can explain from super hexagon. There are multiple things which we will keep learning in the next 5 minutes. Next 5 minutes we will concentrate on super hexagon, because one of the student I think Raj Sharma asked me, sir, how it is -1? Cot square theta minus cosecant square theta is -1, and I don't want you to by heart it as cot square theta minus cosecant square theta as -1. I am teaching you a multiple different beautiful concept which will make your understanding much more easy and simpler. Kindly comment in the live chat if you have understood whatever we have discussed. Kindly comment, sir. These are something which I want my student to learn it, so that it will be very easy in your examination. You need not worry about a trigonometry. You should just worry about whether Ajay sir will take classes or not. Yes, I will not give you that worriment. I will definitely take classes for you and make you realize that the world of aptitude is much more beautiful, like the way, rather than the way you were thinking earlier. Next, now see here. Let me extend the logic of super hexagon. See here, sir. I am drafting that super hexagon once again. I just pasted the same thing so that I will not write it again and again and waste my time. Now see here. If I extend the logic, let me delete all these things which are unwanted things. Let me delete this arrow mark also, which I don't require. Similarly, the arrow mark on the right hand side, which I also might not require. Now see here, sir. This diagram is what I require. Listen carefully. I will copy this diagram for my next explanation once again. Okay, great. Now see here. You might get a question. Sir, whatever we derived just now by using super hexagon, you wrote something called as 1 in between. Whatever, everywhere, whatever it is joining, you wrote something called as 1. We never made use of that value called as 1. What is the use of that 1? It is very easy, sir. This is where I want you to learn so many beautiful concepts in trigonometry or also in aptitude. Now see here, sir. Listen carefully. Can I say that? What is the meaning of that 1? That 1 is very easy. Can I say that? I joined the opposite vertices of this hexagon. If I think like that, this is one of the vertices, sin theta. Opposite vertices is cosecant theta. Sin theta is coming like this. Cosecant theta is coming like this. The product of both is nothing but 1. You already know this, right, sir? Sin theta into cosecant theta. The product is 1 because they are reciprocal relation, or in other words, the opposite vertices form a reciprocal values. Similarly, can I say that cos theta is coming like this, secant theta is coming like this. They both will combine here at 1, which is the midpoint. Cos theta into secant theta. Again the product is nothing but equal to that middle value 1. And the last one is tan theta into cot theta. Tan theta into cot theta. What is the reciprocal product? Product is equal to 1. That means you need not by heart the reciprocal relation which I taught you yesterday. Rather, you can understand so beautifully by using super hexagon. No need to by heart, sir. So many things can be so beautifully unfold, not only in trigonometry, in so many beautiful concepts of aptitude or so many beautiful topics of aptitude. I hope the second logic in my super hexagon is also clear. Opposite vertices will definitely give the product as 1, which is nothing but my middle value. The second value should be very clear. Now see this third value, sir. You will enjoy this third explanation in super hexagon again. You again need not by heart anything in learning this concept. See this third explanation in super hexagon. Can I say that this is another variety what I can implement? Can I say that you take any 3 trigonometric functions which are next to each other. Suppose, for example, if I start with tan, go in clockwise or go in anti-clockwise, whichever the way you want to go, please go in that logic. If I start with tan, suppose if I am going in clockwise direction, tan, sine and cos. These are the three trigonometric functions which I am taking, right? These are the three trigonometric functions I am taking. Start with the tan, write down tan theta, right? Write down tan theta. First value is tan theta, last value is cos theta, middle value is sin theta. Definitely you take any three consecutive trigonometric functions in this super hexagon, the product of first and last will definitely get. What should be the identity again, sir? No need to by heart. I don't want my student to by heart it. If I am starting with cot is the first value, secant is the last value, the product of first and last will give you the trigonometric function which is in between those two trigonometric functions, which is cosecant. Take any three of your choice which are consecutive to each other. Remember, it should be consecutive. Suppose for example, if I take secant, tan and sine, right? If I take secant, tan and sine, what should be the trigonometric function? First one is secant, last one is sine, middle value is tan. So secant into sine will give me the middle trigonometric function tan. Over. Like that you can derive any number of things. You can derive minimum 6 formulas, and I don't want to by heart these formulas. I can derive it whenever I think that I require these formulas. You can easily draw the super hexagon. You can derive all these things so beautifully. Kindly comment if it is clear till this point once again, sir. Cos into cot is cosecant. Now I am starting with cos Purna. You are starting with cos in fact. If I take cos, if I take these three, next three, cos into cosecant is cot Purna. First into last should give me the middle. Not first into middle should give me last. Or in other words, first into second. Sorry, first equal to second divided by third. That is what I explained in my first explanation. Cos is nothing but cot divided by cosecant. If you cross multiply, you will get whatever I am explaining right now. Purna, there is a mistake in you, sir. Whatever you have explained, kindly make that correction. Gaurav, cot into sine is equal to cos. Let me check it out, sir. Cot, where is cot? Cot into sine is equal to cos. Yes, you are absolutely right, Gaurav. You are absolutely right. You can take it in anti-clockwise also. You are absolutely right. Yes, Bharani, you can either take it in clockwise or in anti-clockwise. Now see here, another explanation in this super hexagon. Another explanation. Listen carefully, sir. Beautifully you can unfold these things. Now, you remember I taught you allied angles. I taught you so many things in allied angles till now. And I also taught you one variety in allied angle. If I want to convert sine in terms of cos, write it as cos of 90 minus theta. This I explained you, sir. Yesterday I explained you in detail with concept. If I use super hexagon concept, can I say that if I use super hexagon concept, parallelly go with it horizontally, sin theta can be written as sine and cos will go horizontally. That means sin theta is nothing but equal to cos of 90 minus theta. Or you can go horizontally in the reverse direction also. Cos theta is nothing but equal to sine of 90 minus theta. Similarly, tan theta is nothing but equal to cot of 90 minus theta, right? Cot of 90 minus theta. I hope you are able to understand, sir. Horizontal trigonometric functions, the sum of the angle will be complementary. Similarly, last one is secant theta is nothing but equal to cosecant of 90 minus theta, and I believe that my students are very clear in understanding the concept of allied angles after at least watching this super hexagon concept, right? It is very beautifully derived, sir. You are making it a very big mess. If you are not learning shortcuts in aptitude, you are struggling. You will struggle and you will keep on struggling. The more and more you by heart formulas, it is always better to know the concept behind solving the problems. rather than formula usage of methodologies of solving problem solving. And I don't want you to remember all these formulas, rather remember trigonometric identities in an easier format as much as possible wherever it is possible, right? This is another explanation in super hexagon. Now see here, sir, we all know this beautiful thing. This is where my explanation of super hexagon started. One of my friend asked me how 1 plus tan square theta is equal to secant square theta, how sin square theta plus cos square theta is equal to 1, how you can also say that 1 plus cot square theta is equal to cosecant square theta. Sir, no sir, please do not by heart all these things. Sir, I am not habituated to remembering this formula. No need to remember, sir. I don't want my student to remember. I don't want my students to remember all these values, right? Rather, easily use our logic of super hexagon, which will make you to remember or derive all those things in a much more easier format. Now, can I say that? Listen carefully, sir. You take any three triangles for that matter. Suppose, for example, I am taking these three triangles. This is one of the triangle I am taking. This one is again here, sir, present here. This is another triangle which I am taking. I am marking whichever the triangles I am taking. This is the third triangle which I am taking. Right? Now see here. Can I say that? Start from the topmost thing. First I will explain with the clockwise direction. Right? First I will explain with the clockwise direction. If I explain with start clockwise direction, start your journey with the topmost thing. If I start with topmost thing, and if I draw a clockwise arrow mark like this, similarly for this topmost thing is here. If I start with this and draw an arrow mark like this, you can understand like this. Can I say that? Remember, there is one here, right? Don't forget this one. Anyway, I am writing that one here also, so that you will not forget that one. Can I say that you are starting here? It is sin theta, sin square theta, right? Sin square theta. Here, when you are going, you will meet this person called as cos theta plus cos square theta. And when you are coming like this, you will meet this person called as 1. Sin square theta plus cos square theta is equal to 1. That means, in simple language, first term plus second term square will give me equal to third term, right? Will give me equal to third term square. Similarly, second arrow mark, if I start with this is 1 square. 1 square is 1 plus, if I go like this, I will meet this person called as cot theta. 1 plus cot square theta is equal to, the third term is nothing but in this particular direction is cosecant square theta. I hope the idea is clear, Raj Sharma. This is basically, I thank Raj Sharma so much because he ignited me to explain this concept. I am very, very thankful to you, sir, because of your doubt how cot square theta minus cosecant square theta is equal to minus 1. One small doubt of yours ignited me in teaching a beautiful concept called as super hexagon for my students, and thereby because of one doubt of yours, so many students are learning this beautiful concept. We should definitely thank the student who asked this doubt. Similarly, if I start with this particular topmost arrow mark, tan is the first value, tan square theta, next is 1 plus 1, tan square theta plus 1, or I can also write it as 1 plus tan square theta is equal to the third value secant square theta. Beautifully you can derive it, right, sir? Where is the concept of by hearting these things? There is no way you need to by heart these three formulas. If you know super hexagon, so many things in trigonometry can be unfolded so beautifully and in the most easiest format, in the most easiest way. Now see here, this is the explanation for clockwise. What if it is anti-clockwise? What if it becomes anti-clockwise? It is so easy. Once again, there is no difference if it is clockwise or anti-clockwise. Now see here, I will change the arrow marks of all these three figures or whatever the triangles which I marked. This is the triangle which I am taking, this is the triangle which I am taking, this is the triangle which I am taking. If I draw the arrow marks, if I draw it in anti-clockwise, I will start with this bottommost thing. I will draw an arrow mark like this. I will draw an arrow mark like this anti-clockwise direction. I will draw an arrow mark like this anti-clockwise direction. Please do not forget this beautiful value called as 1, which is present in the middle. Now see here, same explanation, sir. I will start with this 1 square. When it is anti-clockwise direction, second term will become minus. That is the only difference. Minus cos square theta is equal to the third term sin square theta. You know this, right, sir? 1 minus cos square theta is equal to sin square theta, right? Similarly, can I say that if I minus cot square theta is equal to this particular value square, 1 square. This is where we started our explanation, Raj Sharma. Cosecant square theta minus cot square theta is 1, or cot square theta minus cosecant square theta is minus 1. Last explanation, it is secant it is starting with, so it is secant square theta minus next you are meeting 1 minus 1 square is equal to last is tan, it is tan square theta. Over, sir. All my trigonometric identities, so many things we actually learnt in so easiest format. Here you are taking it in anti-clockwise direction. In my previous case I took with clockwise direction. Is there any difference? No difference. Conceptual learning also we understood yesterday. Beautiful shortcut learning also we are understanding today. What else is required for you, sir? What else is required for you? A beautiful concept called as a super hexagon, which will simplify our trigonometric identities to a very easy extent. Super hexagon is what we discussed in the last 10 minutes of our class. Thank you so much for making me to teach you this concept, sir.